What's going on, boys and girls? So today we have a long-awaited version 2.5, and in this video we are going to desolder elements on the filter, on the HF amplifier and on audio amplifier, and we are going to measure everything. We are also going to pop the datasheet for this LNA right here and go over its parameters. And we're going to discuss installation, because there is 3 ways to install this board. There is single antenna, dual antenna, the way it was intended to be installed, and there is also a discrete antenna, and we are going to go over those installations in this video. But this video is just overview. Installation video is going to be the next video. But before we do anything, we have to do something else. Today we have a Pilsner DC made in Sochi craft beer. Sochi is my hometown. Check this out. Let's pop this sucker open. Oh. And let's taste it. It's hot in here, so it's much needed. It's cold. Nice. So guys, let's go under microscope and let's begin overviewing this thing. Check out that filter over there, guys. We have 1 coil, 2 coil and a capacitor, right? Just like on this version 2. We got same 1 coil, you see, coil, nozzle coil, and the capacitor. Over here we have a coil right here, right? And here we have, I believe, a capacitor, and we have it right here. So the filter on this thing is same as on version 2 without the audio preamp. And this right here, I believe, is a 0 ohm resistor, but we're gonna measure it later. So version 2.1, that's one with audio preamp, right? You see the filter, how it uses high quality coils over here. There are more elements. This is not the same as this one. So at least the filter part of this new board is, or version 2.5, is not as good as the previous 2.5. But it's okay, it's still gonna work. By the way, this is not my modification board. I just come from Moscow, and my subscriber gave it to me along with a radio station so that I can make a video for you. Once it's done, I'm gonna send it back to him. Let's go over completion of this board, the things that it comes with. Let me open up this bag. So it comes with SMA connector. SMA connector is of proper length, 18.5 millimeters. I actually asked our guy, the one who's getting this mod done, to get additional 18.5 millimeter connectors in case this one is longer or shorter, but they're the same size, so we're not gonna use this. And what else we have? We have some jumper wire and one of these the coil, this for single antenna setup. But our guy also provided us with high frequency, low ESR SMD coils. So when we're going to do single antenna version of this mod, we're going to use this instead of this thing. straight away answer to a question: do you need the sync? Do you need this coil, or do you need the improved version of this coil? If you do dual antenna, you do not need this coil. But if you do single antenna, then yes, you need this coil. But guys, with this board, even though it is configurable to do single antenna, it's pretty dumb to do single antenna setup with this board, because it has a separate LNA. That means for better, more amplification. Next we have a cable. Let me see the lengths here. The lengths, guys, yeah, the length is more than adequate. So better, it is a little bit longer. That's what I have used, but the connector here is not IPEX. It's something smaller. Let me show it to you. So here we have IPEX, right, on my board, on my radio, and this modification board comes with something smaller. It's going to be MH like 3, maybe 4. So this cable will not fit this, and the cable in the IPEX cable from that fits over here is not going to fit over here. But that's doesn't matter. Just something to note. What else we have? We have 3 100 nanofarad capacitors, one for installation and 2 for me to keep. You're gonna install a 100 nanofarad capacitor whether you're doing single antenna version of this mode or dual antenna version of this mode. But for discrete antenna, you're not going to need one of these capacitors. So let's talk about our options of installation. Single antenna is, we just use a stock antenna like this for both FM and AM and SSB and CW, right? And dual antenna is when we use the stock antenna for FM with this version, with this particular version, stock antenna is going to be used for FM, and for AM and SSB and CW we use a separate antenna. That's a dual antenna setup. This board version 2.5 is actually was intended to be used with dual antenna setup, but there is something else. There is a discrete antenna. Basically with discrete antenna, FM, AM, SSB, CW is used like this. The stock antenna we do not use for this modification. And let me show it to you on under microscope how it's going to look. Basically, we're gonna have our mode right here, right? Basically, for the discrete antenna, we are going to remove this 0 ohm resistor and we are going to install it over here, and signal from the discrete antenna is going to come here, right here, right through this connector. It's going to get amplified. It's gonna go through this trace, and we are going to take another cable and connect signal from here all the way over here, and this trace is cut right here, and signal going to enter here, go through this LNA and going to enter this board and go through this jumper, through this filter, through the AMI pin, and through this capacitor to this filter, to the FMI pin. So that's how discrete antenna is going to work. I'm not sure yet how it's gonna play out. Maybe it's not going to work, maybe it will work, but in the next video we're definitely going to test out our three different ways to install this board. Also, our guy sent us EEPROM. This is very important if you're doing this mod or a different version of this mod. Definitely install EEPROM, because that allows you to install Fox's reborn firmware, which has the capability to work with the SI. Plus it has spectrum analyzer, spectrum band, and a whole lot of goodies. We also have 3 additional LNAs. This is a BFU550AR. 2 are going to go on a different side of the board for the SATCOM mode, and 1 is going to be installed right next to this mode, into the place of the original LNA right here, so that our guy gets more FM stations. Also we have coils for the SATCOM mode, and he sent us pigtails, which we are not going to use because we're going to use the stock pigtail, different size, but we might end up using them anyway. I'm not sure yet, guys. So for the question some of you asked before in the comments, and for all of you new subscribers who's coming up and watching this video, why am I wearing Z? Have you guys seen the Homo Olympics, the opening scenes? I saw it yesterday on the Telegram. Guys, I'm against that shit. That's why I'm wearing Z. And you can also wear one of these badges. Let me show you where to get it. You can get them on AliExpress. I'm gonna include the link. You can get all kinds of badges. Z, V, whatever. I'm going to include the link in the description, so if you're interested, get one of those badges and wear them. Be against the homo shit. Guys, this is the radio that our guy gave it to me. Basically, let's take a look at it. Check out the button. He printed it himself on the 3D printer. So this is the K5, not K6, K5 or K5-8. This is a K5 original, and I'm going to do comparison between this radio and this radio. They're the same if you look at the board, but the body is different. So watch for a different video where I'm going to compare. Basically, I did not know that this radio, when I saw it on the internet, the pictures, right, I said this looks funky, but when I actually hold it right now, it feels really good quality. We also have this thingy. He printed it on 3D printer, so you can just put your radio. We're gonna hold it right there. It's a radio holder, and we have 2 boxes. I'm gonna show it to you later in a different video, but basically these boxes replace your stock battery with a much larger unit. So with this thing we have this first video, second video installation, third video is testing, comparison of version 2.1 and 2.5 on reception, and then we have a comparison of this radio with that radio. We have like 4 videos, guys. So guys, let's get down with this video and finish it up, because our guy, I'm pretty sure he wants his radio back as soon as possible. So we gotta do this quickly, so and send it back to him so he can enjoy his radio. And let me just taste some beer. And let's go down on the microscope and unsolder some components so we can measure stuff. So we are cooled off and our LCR meter is zeroed, and off camera I removed the amplifier section. The amplifier, audio amplifier, this time around is A63A. I'm not sure what this marking is, we're going to look this up later, but this is different from what it used to be. So let's measure this capacitor right here. I'm measuring it at 100 kilohertz, by the way. It reads 89 nanofarads, so we can safely assume this 100 nanofarad capacitor. Let's write it down as 100 nanofarad. And F. Well, let's go right and measure this one. So this one says it's 3 UF, guys. This one is a 3 UF capacitor. How about this one? This one is, it says 2.8, 2.9, but it's a 3 picofarad capacitor. 3 PF. And we got the resistor over here. Let's measure the resistor. This is 4.6 kilo ohms, 4.7 I would say. It says 4.668, so let's call it a 4.7 kilo ohm resistor. 4.7 kilo ohm. And next we have a capacitor. So let's measure the capacitor. The capacitor, oh come on man, it's 3.6 UF. It says 3.6 UF, guys. So let's write it down as a 3.6 UF. And next we have, let's measure this resistor, right? And then we're gonna go here, here, and here. So let's measure this resistor first. And this resistor is, it's a 1 kilo ohm resistor, guys. 1 kilo ohm. 1 k ohm. And we're gonna measure this line first. This resistor, this capacitor, and then this resistor. So this resistor is it's a 6 kilo ohm resistor, guys. And let's measure this capacitor. This capacitor is it's climbing. Fuck, man. .5 UF, guys. Let me spray it with some cleaner and measure it again, just in case. Lowered frequency to 4 kilohertz. Yes, guys, it's a 3.5 UF confirmed. So let's measure this last resistor over here. And this resistor is 9.6 kilo ohm. 9.6 kilo ohm. 9.6. So this is audio. How about the filter? Frequency is back to 100 kilohertz. First of all, let's measure this resistor. I suspect this is 0 ohm resistor right here for board configuration. Yes, this is a 0 ohm resistor. So let's put this value down. This is 0 ohm resistor. And let's measure this capacitor. This capacitor is, it's 21 picofarad. Yes, let's call it a 21 picofarad capacitor. 21pf, and this coil is guys, back down to 1 kilohertz. Let me spray this shit and clean it. Back to 120 Hz. Down to 100 Hz. Nope. 120 Hz. Guys, I'm not sure my thing cannot measure this low, but it's between 1 and 5 UH. Let's write it down as a 5 UH. But this is not accurate reading. So what next we have? We have nozzle coil right here. Let's measure it. And this one, again, this is a not accurate reading. It is between 6 and 1 UH. Let's call it a 5 UH. Let me raise my frequency to, I don't know, let's put 100 kilohertz and try it again. .5 UH. This is a 1.5 UH. And let's come back to this coil. What happened here, I'm not sure. .12 UH. Yeah guys, this is a 0.12 UH. So let me change the value here. 12 UH. And let's do the next coil. .7 UH. 4.7 UH, and we have one more capacitor over here. There you go. And it is 1 picofarad capacitor, guys. One picofarad. So guys, let's put this filter part back together and then put the audio part back together and move on to the LNA part and measure it. So let's do the LNA. I'm removing it so that I don't overheat it. Overcook it. Yeah, that should be good. So let it cool down and let's come back and measure everything. So guys, this is day 2 and we are back. Let's measure things in the LNA section. I see this resistor. Let's do it first. And the server says it is 0.06 ohm. This appears to be a 0 ohm resistor. Yes, this is a 0 ohm resistor. So let's write it down. And next we have a capacitor. So the capacitor is The capacitor is 89 nanofarads, like 90 nanofarads, but more likely this value is 100 nanofarads, and just a plus or minus plays out. So let's write it down as 100 nanofarad, 100 NF, and below that we have another capacitor, so let's measure it. It is 50, 52, 53, 54, 60 picofarads, 65, 66, 67, 70 pf, 90 pf. Now it went into an F right now, so let's try it again. (92 NF). Yeah, 92 NF. So I'm gonna write it down as 100 NF as well. 100 NF. And let's measure capacitor below that capacitor, this one. 86 NF. I'm gonna write it down as 100 NF, guys. NF. and it makes sense, guys, because here we have plus 3 volts, right? And that plus 3 volts going through 0 ohm resistor, and we got 300 nanofarad capacitance here, 3 capacitors, 100, 100, 100, and it going to the positive pin of the LNA amplifier. So let's measure these two, this entrance and exit capacitors, and the capacitance is 100 picofarad. It says 97 picofarad, guys, but this, I'm gonna write it down as 100 picofarads. And how about this one? Come on, give it to me. 99 picofarad, 98, 99. So it's both of them are 100 picofarads. Let's write it down. 100 pf, 100 pf. And at this point we have measured everything, so let me come back and put everything back together. So guys, we are back, and by the shaking loops of things, you know that hot air is working. So let's give it some flux. Yeah, some flux generously here, and let's put everything back together. I'm burning my fingers right now. Come on, come on, give it to me, son of a bitch. Maybe we need some more air, like 80% more. Oh man, this is hot. How about this too? And let me put back this LNA. Now you see the big pin, right? That's a minus, so we know how it goes. I think we did it. At this point, let's go over everything one more time and check out different configurations for this board. And also let's look at data sheets for the RF amplifier and the audio amplifier. Let's go under microscope. So the signal enters over here from the second antenna. This is for AM SSB-CW signal, and it hits this TVS diode. This way, in the winter, when you get a spark, when you get electrified with a sweater or something and spark flies over antenna, you do not burn this LNA or this chip. Signal travels to this capacitor and hits this amplifier. This amplifier has a marking BMS, and this amplifier is let me show it to you. It is a BGA427. As a matter of fact, I have some BGA427s right here. So essentially, in one of the future videos, I'm gonna take version 2, but this is as well could be version 1, the green board, or plethora of other different boards, including version 2.1, which does not have the LNA, and we're gonna install one of these LNAs just like on this board. So let's go back to the data sheet. Basically, this LNA provides typical gain of 18.5 decibels, and the noise figure is 2.2 decibels, which is not bad but not good either. There are two ways of implementing this amplifier, right? This LNA. We see the first way implemented. Basically, let's see here. Let's go under microscope. We see here negative, right? And here we see positive, and this is think of it as like one capacitor. So what we see here on the data sheet, we have negative, we have positive, and we see one capacitor. But here it says 1 NF, and on this board there are three 100 NF capacitors, so it's 300 nanofarads. And we have 100 PF entrance and 100 PF exit capacitors, which, let me check, what did we measure? I forgot already. 100 PF and 100 PF. That's what we measured. Let me show it to you. You see, we measured 100 PF and 100 PF capacitors. I'm talking about this capacitor and this capacitor. So let's go back to data sheet, which is the same thing as on data sheet. 100 PF and 100 PF. There is a different way of implementing this LNA, and it's pictured over here. So where is the figure 1? Application 1. Oh, it's all the way on the top. So with application 1 we get 18.5 decibels of amplification, and the noise figure is still 2.2 decibels. but with application 2 we could have get 22 decibels of amplification with the same noise figure. I went to Moscow and I actually bought a whole bunch of components just so that we can implement this LNA over here. You see the stack radio, right? I mean, not stack radio, this is version 2.1, and we're gonna install LNA right over here. Right now I have a BFU 550 AR, and in one of the episodes we are going to put this LNA into that radio, so it's gonna be the same thing. Let's go further and explore how this thing works. So the signal travels through this capacitor, gets amplified, and exits through this capacitor and goes over through this trace. This is a 0 ohm resistor. It goes through 0 ohm resistor and through this coil and this capacitor, and this is a AMI pin. This pin is used for AM SSB CW signal, and this is a FMI pin. It is used for the FM signal. FM signal, it goes through this capacitor. It comes from here, right? On the Kwangshank from the stack antenna, here we have a LNA. It gets amplified and it goes through here, through this capacitor and into the FMI pin. Basically there is 3 ways of installing this radio. Like I described, this is a dual antenna, but we can also configure a single antenna. For that we remove this 0 ohm resistor, disconnecting this signal right from this amplifier, and install it here. This way signal from here goes both to AMI and FMI pins. That would be a single antenna setup. There is also something called discrete antenna. That's when we also remove this 0 ohm resistor installed here, but we take this signal that we just amplified over here, we take it from here and we inject it. Let me show it to you on this radio. So we take that amplified signal. Keep in mind this trace is cut from the stack antenna, and we inject it over here. It gets amplified through the stack LNA. Well, I don't have a stack LNA here, I have BFU 550 AR, but imagine that you have a stack LNA here, and then it goes through 2 amplifiers basically. That would be a discrete antenna setup. So we're gonna try a discrete antenna setup in our upcoming video on the installation of this version 2.5. There is a different and better LNA out there. It is SPF 5043Z. Basically, just I went through hell trying to get this thing ordered. I already ordered it. It wasn't available on AliExpress, and I had to write Vladimir Putin and complain, what's going on, guy? We in China are friends, right? And this shit is not available on AliExpress. We are under sanctions or something. And I quickly got a response. So basically they told me you are searching wrong, but I wasn't, and that thing overnight became available, so I ordered it. This amplifier LNA, right? It amplifies 18.2 decibels, same as BJ427, but the noise figure is 0.8 decibels versus on BJ427 we got 2.2 decibels. But there is also a minus. This thing supposedly works only 50 megahertz and up to 4 gigahertz, so it might not work for this application with a HF, but we're still gonna try it once it arrives. Maybe it will work, I do not know. I'm definitely gonna try it. The SPF5043Z, it's true. It's true. I'm looking for a word. Well, I'm not supposed to. You're not supposed to install for the HF LNA, right? It's used for the LNAs on the back. Let me show it to you on the microscope. You see this two right here for VHF and UHF. Right now I have BFU 550 AR installed, low noise LNAs. These LNAs amplify your VHF and UHF tracks. So the original idea comes from another guy, was to install SPF 5043Z into here. Let me show you something. Check this out. This is a Kwangshan, guys, and check this out. You see this thing modified over here. It has two of these amplifiers on these LNAs. So that's the future, guys. That's what awaits you if you subscribe to this channel and stay tuned. If you haven't subscribed yet, click that subscribe button and notification bell, and if you haven't done so, press the like button. I got carried away, guys, and we almost forgot to look at the audio amplifier, so let's do that right now. So, audio amplifier. Basically we have left audio, right audio pins, and they connect over here and go through this via, I'm assuming pretty accurately, they exit right over here, and through this capacitor they go into this amplifier and get amplified and exit over here, and through this capacitor go through this via, and down here they exit from a via, and they hit this pot. Amplified signal hits this pot. The audio amplifier this time around has a marking A63A, which is, let me show to you, which is, come on, oh, PDF. It's a National Semiconductor LM321 low power single op amp. Basically it's a different thing. Part number is LM321MF or LM321MFX. Previously we had SG Micro SGM321, which was rail-to-rail I/O CMOS operational amplifier, but it's the same thing, guys. So nothing changed with the audio amplifier. And by the way, guys, I have here 10 pieces SGM321 audio amplifiers, and when I'm going to install version 2, but this as well could be version 1, the green board, the original, I'm going to install both audio amplifier and the LNA. So another reason for you to subscribe, guys. Let's look at crystal. Let's see what the markings are. You see it? It's J, Jerry, A, Adam, 4, C, Cherry, 3. I do not know what this crystal is. I guess you're gonna have to look it up yourselves. Guys, there is one video that you guys are missing that I shot it, but I haven't released it yet. I shot it right before going to Moscow, and I did not have time to release it. But in that video there is a lot of foul language, and I don't think I'm gonna release it. Maybe I'm gonna shoot a different video. Basically that video is about LNA, guys. We're talking about this thing right here. This is a modified LNA. This BFU550AR from factory. That LNA is 2SC4226 from factory. But I installed BFU550AR, and if you watch my channel, you remember that I had a video when I show you, in which I actually show you that when we connect antenna over here to use this LNA, right, it did not work. We only get static. We only got signal when we connected antenna here, and that, guys, is pass. I'm guessing, I'm not sure 100%, but I'm guessing that was because of the air defense systems and jamming, basically, military protecting us. But at this point in time, enemies taking heavy losses. They got pushed way far, and there is less of that stuff. I wouldn't say it's gone. Their defenses, right, they're still there, but less of that stuff is here. And for me to receive HF on 40 meters, I just take my radio, stick my hand outside the window, and I get a reception. It works now. So you're missing one video which I haven't released about me installing this LNA. Keep that in mind. Let's try a conclusion in the next section. So guys, let's conclude. Basically, this version 2.5 board with audio preamplifier and LNA has same exact filter as version 2.0 without audio preamp, same exact filter, which is not bad, but it's not as good as version 2.1. I hope they come up in the next version, improve this filter, and stick the filter from version 2.1 into here. Then I'm definitely buying this board, guys. Audio preamp, different part number is used, but that part number is analogous to SGM 321 that was used on version 2.1, so it's the same thing, guys. LNA, guys. LNA is BGA427, which provides 18.5 decibels of amplification and 2.2 decibels of noise. Noise figure is not atrocious, but it's not good either. Stock LNA that comes with Kwangshank is 2SC4226. Let me show it to you better. You see it now? It's 2SC4226. That's a stock LNA, which has noise figure 1.2 decibels. I know it's not linear scale, but it's let's say it's twice less noise than on the new board. But amplification is also twice less at only 9 decibels, guys. That means if we take radio with stack LNA and version 2.1 board. This is not a stack LNA, by the way, but if you take a stack LNA, stack radio with version 2.1 and a modified radio with version 2.5, version 2.5 is going to be more sensitive. But as you know, this is a modified radio. It has a BFU550AR LNA. Let's look at BFU550AR LNA. Gain is 18 decibels. Gain is almost the same as on the new board on the version 2.5. The BJ427 provides 18.5 decibel gain, and BFU550AR, which I have installed over here, provides 18 decibels of gain. And the noise figure, that's the most important thing, guys. This thing is really low noise, 0.6 decibels. That means if you take my radio with modified LNA and version 2.1 boards and a radio with this new board version 2.5, my radio is going to be a lot more sensitive than version 2.5, because BJ427 LNA that comes on this board is kind of noisy. That's why. Yeah, but that's everything is theory, so practice is going to show. I'm going to test everything in installation video because I have that ability right now. And keep in mind, I ordered 4 BJ427s for exactly for this purpose, to install as LNAs, and so hoping that is going to be good, guys, but I don't know. We'll have to test and see, guys. Anyway, if you like this video, press a like. If you haven't subscribed, subscribe and hit the notification bell. And I'm going to see you in next video where we're going to install this new board into that radio. See you.